Hello everyone, welcome to another episode of Rectilinear Motion. This is Raja Banerjee from Finland Institute of Physics. Today we are going to discuss different cases of rectilinear motion, that is one-dimensional motion. In our last episode, we have seen that when an object is in motion and we need to find how much distance it is traveling in a larger or smaller interval of time, we follow a simple unitary method and named it as speed. We can also find in which direction the object is going by following the same unitary method, but this time we named it as velocity. Suppose an object at time t equal to 0 is at origin, that is at point O, and after time t1 it is situated at point A, which is at a distance x1 from the point O. And suppose after time t equal to t2 the object is at point B, which is at a distance of x2 from the origin. So if we want to define velocity now, then velocity should be defined as change in displacement by change in time. That is x2 minus x1 divided by t2 minus t1. So delta x divided by delta t. Therefore delta x, that means how much distance the object is covering in a time of delta t, we can find out by the simply multiplying this velocity, that is the factor velocity, with time. So if a car, say for example, traveling with a velocity of 60 km per hour and we want to find how much distance it has been traveled in a time of 3 hours, then we just need to multiply this 3 with the factor velocity, and the distance covered will be 60 into 3. That means the distance covered by the object, by the car actually in 3 hours will be 60 plus 60 plus 60, that is 180 km. Similarly, if we want to find how much distance it has traveled in a smaller interval of time, say half an hour, then this time we need to multiply this velocity with half, because this time the time is half. So it will cover 60 into half, that means 30 km per hour. But in this equation, s is equal to vt, s is a dependent variable between v and t. So during the motion, if v changes, then we cannot determine this s, or distance covered by the object. So depending upon the velocity, we can classify the motion of the object into two categories. The first kind of motion, in which the velocity of the object remains constant, that means everything remains uniform. So this kind of velocity is known as uniform motion. And the second type of motion, in which velocity changes. So nothing remains uniform. So this kind of motion is known as non-uniform motion. So we cannot simply use the formula s is equal to vt here. So in order to define this kind of motion, we need another parameter which actually denotes the change in velocity with a change in time, that is acceleration. And in order to define this acceleration, we can follow the same logic which we had followed during defining speed and velocity actually. That means in an interval of time, say delta t second, the change in velocity is delta v. Then in 1 second interval of time, the change in velocity will be delta v divided by delta t. And that will obviously be acceleration. Now obviously this acceleration is a vector quantity because we have velocity in its formula, and also it is following the same footprint as of displacement following in the space. So we can graphically represent it using vector, and hence we can find its unit also from its formula, that is acceleration is unit of acceleration is unit of velocity by unit of time, that is meter per second by second, that is meter per second square. So do in CGS system it will be centimeter per second square. Now this change in velocity can occur uniformly, either uniformly or abruptly, depending upon the force which is acting over the body. Like for an example, in case of a freely falling body under gravity. So in that case, the force acting over the body will always remain constant. So it will produce uniform change in velocity in a particular interval of time or in a certain interval of time. So the change in velocity with respect to time always remain constant. So this kind of motion, so acceleration will basically be constant. So this kind of motion is known as uniformly accelerated motion. But there are certain cases where the change in velocity with respect to time, that means in a certain interval of time, the change in velocity does not remain constant. This kind of motion will be known as non-uniformly accelerated motion. So we can extend our chart of motion further into two categories. That means we can divide motion into uniform and non-uniform motion. Also, this non-uniform motion can also be further subdivided into two categories. The first one is uniformly accelerated motion, and the second one is non-uniformly accelerated motion. And simply we cannot use the formula V is equal to delta x by t in that case, because it is not an uniform motion. Instead, we use three different types of relation. The first one is velocity time relation, that is V is equal to u plus at, and the second one is displacement time relation, that is S is equal to ut plus half at square, and the third one is velocity displacement relation, that is V square is equal to u square plus 2as. Now this force can act on the body into or opposite to the direction of the motion of the object. So when the force is acting into the direction of the motion of the object, then its change in velocity will be a positive one. Therefore, there will be acceleration in its motion, because A is equal to positive change in velocity divided by time. But suppose when the force is acting opposite to the direction of the motion of the object, then in that case, change in velocity will be a negative one. So acceleration will be negative change in velocity divided by time, and that will be retardation. So we can further modify these formulas, velocity time relation, as V is equal to u plus minus at, S is equal to ut plus minus half at square, and V square is equal to u square plus minus 2as. Also, we can define these formulas, we can modify these formulas for a particular situation, like motion under gravity. Suppose we are throwing a body upward. So in that case, the motion of the object is in the upward direction, and the force of gravity will be acting on downward direction. So the force acting opposite to the direction of the motion of the object. So in that case, we need to take the negative sign, and we should modify the formula. We can use G, that means acceleration due to gravity, 9.8 meter per second square or 980 centimeter per second square, in place of acceleration, because we know for that specific condition acceleration is acceleration due to gravity. So in that case, we can write our formulas as V is equal to u minus gt, S is equal to ut minus half gt square, and V square is equal to u square minus 2gs. Why the negative sign? Why we are using negative sign? Because here the motion of the object is on the opposite direction to the force applied over it. And suppose the body is falling under the motion of gravity. That means a freely falling body. So in that case, the motion of the object will be in the direction of applied force over it, that is acceleration. So for this specific case, we can use the formula, we can use G in place of A, and we can write our formulas as V is equal to u plus gt, S is equal to ut plus half gt square, and V square is equal to u square plus 2gs. Now these formulas we cannot use in case of a non-uniformly accelerated motion, especially when we are dealing such kind of motion where the change in velocity is occurring in very short interval of time. Because in that case, we cannot define acceleration, because acceleration is delta v divided by delta t, and in this particular case, delta t is very small. So we have to adapt the mathematics of limit, that means calculus. So in our next episode, we will learn how to develop this particular branch of mathematics, that is calculus, from the motion of a freely falling body. But before that, we need to know certain aspect of rectilinear motion, like average velocity and instantaneous velocity. So in order to know that, stay tuned for the next episode of rectilinear motion. Thank you for watching. This is Raja Banerjee. Goodbye.